2e, we have the integral of x over the square root of 3 minus x to the fourth. Again, this looks rather complicated. It's got lots of different functions going on, or at least a couple of different functions. So maybe we need to do a substitution again. So let's consider some possibilities. I suppose one thing we could do is to choose u to be what's inside the square root symbol. So we could let u be 3 minus x to the fourth. If we do that, then du would be negative 4x cubed dx. And we don't have the right power on x. I suppose that's going to be kind of problematic too. So that doesn't really, that doesn't sound like the right choice. Another possibility would be to let u be the square root of 3 minus x to the fourth. In other words, 3 minus x to the fourth to the 1/2. But then du is going to be 1/2 times 3 minus x to the fourth to the negative 1/2 times negative 4x cubed using the chain rule. And we've got a whole lot of stuff here we need a lot of stuff here that we don't have. So that also doesn't seem like a good choice. So what are we going to do? Well, maybe one of those forms involving the inverse trig functions is the way to go. So here they are. So let's see, this is a constant minus a function under a square root. That looks the most like this thing. So maybe the 3 should be a squared and the u squared should be x to the fourth. Let's try that. Let's let 3 be a squared so that a is square root 3. And then let u squared be x to the fourth. That tells us then that u would be x squared. So du would be 2x dx. And that's looking, let's see, so we would have the a squared minus u squared down here, and we have to find something to do with the x, and it looks like it's going to fit into the du very nicely. So how about we do this? Du over 2 equals x dx. So then our integral becomes, well, the x dx, that's du over 2. We have to fit, and let's see, they don't have 1, and then this is going to be the a squared root 3 squared, and that's u squared squared, right? That's u squared, so that's what we'll have there. Now, I'm going to pull the 1/2 out to the front. 1/2 times the integral of 1 over the square root of square root 5 squared minus u squared. That's looking pretty good. So going back to our form, we want the arc sine of u over a. The 1/2 of course stays, so we'll have arc sine of u over a, which is the square root of 5. And so we have 1/2 the arc sine of x squared over square root 5 plus c.